I never really thought that I would want to return to this 3D collisions in GameMaker series after spending like 2 years on it a while ago, but sometimes things just happen and here we are. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and this is going to require some backstory. So, I've been thinking a lot about collisions in GameMaker recently. I recently made a couple of beginner videos on 2D collisions in GameMaker. I also went and made like a 3D collisions bonus video where I just used that 2D collision system in a 3D environment. And today we're going to go and do a bit of a hybrid approach in that we are going to use GameMaker's 2D collision system to speed up the 3D collision system that we wrote all those years ago. So the way that this is going to work is we are going to use GameMaker's 2D collision system as the broad phase, or basically the first pass, to find out what 3D collision objects are nearby and worth even considering for collision detection tests in the first place. So, in this 3D collision world, we have 2,000 collision objects according to this number up here. Whenever you do an overlap test for 3D collisions, you probably don't want to do... The lighting on this, like, 2D character in this 3D world is really funny. At harsh angles. You probably do not want to do a collision detection test against all 2,000 objects in this collision world. Most of them are not anywhere near us, and even considering them for a collision detection test would be a little bit silly. So what we do instead is we've built a couple different types of hierarchy that allows us to sort the objects in this 3D collision world in a more intelligent way, which allows us to only do collision detection tests against objects that are at least in the same part of the world as us, maybe not immediately in our vicinity. And we've got an octree, a quadtree, which are sort of 2- and 3-dimensional versions of the same data structure, and also a spatial hash, which we can do this with, and it works fairly well. We are able to subdivide the world a couple of times on different dimensions and axes, and we are able to use that to figure out what collision objects are at least within the same, like, relative proximity to us before we do the more expensive and exact 3D collision tests. And what we are going to do today is we are going to use GameMaker's 2D collision system to do that broad phase test instead of using the collision hierarchy that we wrote. So, for those of you who don't know, GameMaker's 2D collision system is unbelievably fast. Even if you were to somehow get your GML code to execute as fast as something like C compiled to native machine code, you would have a hard time making something that is faster than GameMaker's 2D collision system without chopping off features. And the reason for that is that GameMaker's 2D collision system, on every platform except for HTML5, and we don't talk about HTML5, so we'll just say for every platform, GameMaker's 2D collision system will do something more or less like what we're doing here. It won't exactly use a quadtree or an octree. A quadtree doesn't make sense in 2D anyway. It'll use something called an R-tree, which is like a slightly different quadtree, which partitions the world a little bit more intelligently than what we're doing. And what we are going to do in this video is we are going to lean on that for some faster collision world broad phase than what we were doing before. So, I should say, I did sort of come up with this idea myself. I first thought about it back when I was doing sprite packing back at the end of last year, because I used GameMaker's 2D collision system to basically figure out if rectangles were overlapping each other faster than having to iterate over all of them myself. And I don't remember if this was before or after. I also talked a little bit with Juju Adams about doing something like this. And he said he used it in one of his own 3D collision projects, and it worked out pretty well. So, I'm gonna claim like 50% credit for this idea. And also, I'd be surprised if I was the first person to do it regardless, because it seems like the sort of thing that somebody at some point would have tried. So the way this is going to work is that we have our collision world, which is basically a wrapper around the acceleration structure, which can be a quadtree, an octree, whatever. We're going to leave that alone, and we are going to focus on implementing a new acceleration structure type. So I'm going to call it function call world GameMaker. That's going to be a constructor. We are going to need to implement a couple of the common methods that are shared in common between different acceleration structure types. So add, remove, check object, check ray, and get objects in frustum. We're not going to do split. That is there because octrees and quadtrees are recursive structures. But anyway, I need add is going to be a method. We need remove. It's going to be a method. We need check object. We need check ray. This is going to take a array that you're checking with, hit info and collision filtering information because the arrays don't automatically come with it. And lastly, get objects in frustum. I'm not going to try and spell that. So I'm going to copy and paste. Depending on how long this video takes, I might or might not get objects in frustum today. Regardless, once we get used to how this works in general for regular collisions, it shouldn't be too much of a leap of logic to implement it for get objects in frustum. This is already probably going to be kind of a long video, so we'll see. Anyway, so pretty much everything we do today is going to be involved in just filling in this and implementing Cold World GameMaker. There is a little bit of stuff we've got to do on the side, though. For starters, actually creating a GameMaker object. Okay, it didn't allow me to actually type a name into there for whatever reason. We're going to actually create a GameMaker object. We are going to create a sprite to go with it. SPR call proxy and OBJ call proxy, or what I'm going to call it. So the sprite, I'm going to make this a 1x1 white square. It's obviously not going to be visible. This is just a sprite that is there so that we can participate in collision checks. We will uncheck that visible checkbox. We will assign that sprite to the object. I'm also going to go into variable definitions, and I'm going to create a variable, and I'm going to call it a reference, because we do need a way for... let's set that as an expression and initialize it to undefined. We do need a way for these proxy objects to be able to refer back to the collision objects that they represent. And that's pretty much all we need here. So, about the sprite, this is a 1x1 white pixel. We will scale it using image X scale and image Y scale to cover whatever span on the XY plane that any given collision object occupies. And I think that is what we are going to talk about next. So, let me scroll up a bit to the call object constructor over here. I'm going to first define a new variable, and I'm going to call that proxy, and we're going to initialize that to undefined. I'm going to define two new methods, which is going to be create proxy and remove proxy. I keep typing a full colon instead of a semicolon there. So let's fill these in next. When we create a proxy, I'm going to check first if not instance exists the proxy there, and we're only going to create a new one if we don't already have one, if this object doesn't already have one. It is possible that this might be, that you might call this create proxy method on an object that already has one, if it's already part of the collision world. So we're just going to simply only create depth. We're only going to create a new one if we don't already have one. Let's just initialize the x, y, and depth to 0, 0, 0, because we're going to reset that in a minute anyway. The object type is going to be call obj call proxy, I'm sorry, and our variable definition struct. So I do want to assign the ref value here so that the instance that we create does have a reference back to the call object that it represents. I wish it was as simple as just saying ref colon self in the variable definition struct, but the GameMaker scoping rules for anonymous structs like this is weird, and this will actually not work. The self in this scope is now going to contain a reference to the, like, anonymous struct itself, and not the instance of call object that's running this code. I don't like it. I don't know why it ended up that way, but it is what it is. So what we can do instead is you can either do it indirectly by saying this object equals self and then using a reference to whatever that is, or you can just skip the variable definition struct entirely and say proxy.ref equals self, like a regular variable. That's also allowed. Anyway, so now that we've ensured that this is created, we can actually set the position and the scale of our proxy object. So proxy.x is going to be equal to, and I should probably explain this first. I believe this was done in the optimization video in the 3D collision series, but pretty much every collision shape is going to have a property underscore min and a property underscore max, which is going to basically define the minimum bounding box of the object. And for some shapes, such as the axis aligned bounding box, that's pretty easy to figure out. It's just the corners of the box. For some shapes like spheres, it's going to be the minimum extent of the minimum and maximum extents of the sphere on the x, y, and z axis. And this is a sometimes convenient property to be able to access, even for shapes that are not themselves boxes. Every shape has it except for the the planes, because planes are infinite and the concept of a bounding volume of a plane doesn't really make sense. And also rays, because rays are also infinite. Rays don't really count because you're not going to add them directly to a collision world anyway. But we will need to make exceptions for planes, because the infinities that come with planes, and if you're using a plane to represent the ground, will get in the way. But I'll address that a little bit later on. Anyway, so if I want this white square to cover the span of one of these shapes, just like the bounding box on the XY plane, we're using GameMaker's 2D collision system, so we'll just ignore depth. I can say proxy.x is going to equal shape.property_min.x. Proxy.y is going to be shape.property_min.y. The image x scale is going to be the difference. So the length, the side length on the x-axis. So that would be property max.x minus property min.x, and same thing on the y-axis. So property max.y minus property min.y. That can be the image y scale. So if you have, for example, a shape whose bounding volume has a dimensions of 5 on the x and 10 on the y, then the max x minus min x is going to be 5, and you can set that to the image y scale. Max y minus min y is going to be 10. Set that to the other one, and that's going to cause the proxy object to end up in the right place. So one last thing for this, I do want to add a check just in case you try to call this on something which contains a plane. So we can say if shape.property_min equals undefined, if you're trying to call this on an object whose shape doesn't have a min or a max, then it's not going to make sense to do this. That should be not equals undefined. It only makes sense to do this if the shape actually has a defined bounding box. And I am also going to have this return true if the proxy is going to be created successfully, and return false if it isn't. We're just going to use this as a bit of a shorthand to be able to tell if later on in the code if we're going to need to write some special handling for these. And we're going to remove proxy is going to be pretty much what you expect it to be. If instance exists, instance destroy. And I guess for good measure, we can set this to undefined. And we can also have this return true or return false if there was no object to destroy. That's a little less important, I think, but definitely you need to put in the safeguards around the creating it. You could also, if you really wanted to, you could also just not have planes. If you wanted to represent the ground, you could just use a really wide ab or something like that. It's not that important. Anyway, if I scroll down a little bit to where we actually go and implement this, we are going to need to do a few things. I should probably go and make myself a commit here. This feels like a good point to make a commit. I'm going to want to start with add. So in essence, all we really need to do to add an object to this GameMaker collision world will be to say object.create proxy. And this is going to ensure that it has one of these GameMaker objects to go with it. And those GameMaker objects are what can participate in collision checks for us. Because we do need to handle the infinities, I'm going to create just an array. And we can check if So if create proxy returns true, then you don't have to do any special handling. Else, if it returns false, we're going to need to array push onto the infinities array, the object, and then we'll handle those separately. Remove is going to be very much the same. We can say object.remove proxy. And in the case that we want to handle the infinity, we can say if this function returns true, then you're fine. Else, then you'll need to say, let's call it infinity index array get index. The array is going to be the infinities array, and the value that we're going to try and search for is going to be that object. If infinity index is greater than or equal to 0, then array delete. We're just going to remove that from the array. So that's remove. That's pretty easy. Next, let's go and look at check object. So the check object method, this is going to return a reference to the first collision object that the system detects a collision with. And when I say first, I don't mean in any ordered sense, like the nearest object to your to the shape or anything like that. It's just when the system queries the hierarchy, just the first time that it happens to run into a collision, it's going to just return that object. You could, if you wanted to, you could modify this so that it returns an array of objects or an array of every object that it runs into. It doesn't... I'm not doing that here. That will add some, but admittedly not too much complexity on top of what we've already written. But let's start by... I think I'm actually going to start by doing the handling the infinities, so the special cases. So to handle the infinities, I'm just going to go and iterate over... the infinities array. Yes, you can use whatever other notation for this for loop that you'd like. I'm not going to, because in most real world cases, this array is probably not going to be longer than 1 or 2. But let's say possible collision is going to be equal to self.infinities index I. I don't think that's how you spell that word. This is going to be a call object, and we can simply say if possible collision dot check object return true. So this is pretty much the same as the other collision checks that we've done before. That's just going to get the special cases out of the way. If you don't happen to be colliding with like the ground plane or anything like that, we can use the instance place list function, and this is going to be our like the most important line in this video, right? So the instance place list function is very much like the classic GameMaker place meeting function, except instead of returning a just a true or false if a collision is detected at a location, it will populate a list with every collision that was detected at a particular location, at a particular X or Y location. So we will need a DS list for this, and I can say var hit list equals DS list creates. I'm calling it hit list because I think that's funny. The instance place list function I will need to run in the scope of a GameMaker object if I want it to do anything useful. So right now it is not. Right now, if I run this code here, it will run in the scope of this constructor, which is not really going to do anything useful. What I really want is I want this function to run in the scope of the object's... Oh, that's one other thing that I need to do. I need to ensure that the object's collision proxy exists, which I can do by saying object.create proxy. This can fail if the object that you are checking actively against the collision world with is a plane. I can't see any real reason to why you would ever do that. So if that happens, I'm just going to let it fail instead of trying to handle it. Because if you wanted to handle that, you'd have to basically either create a fallback data structure, an octree, a quadtree, or something like that, and check for collisions like that. Or you would have to just like brute force it, iterate over every instance in the world, which nobody wants to do. Anyway, for this I can say with object.proxy, because that is going to cause this code to now run in the scope of the GameMaker object. GameMaker object, the collision proxy. If instance place list if instance place list self.x y, the object type that we're going to look for collisions with is going to be obj call proxy. The list that we're going to use is going to be this hit list. Ordered, I'm going to set that to false. We don't have to sort this list in any way, shape, or form. And now when this function runs, it will populate the hit list with all of the other instances of obj call proxy that it happens to run into. This function will return the number of collisions found, which is occasionally convenient. So you can say like var n equals that, or var count equals that, if you want to know how many there are. And then we can simply iterate over. We can iterate over the hit list, and we can check all the potential collision objects to see if there's an actual collision. So it is possible, this is our broad phase, this is going to narrow down the list of things that we could possibly be colliding with. So for that, we can just say possible collision equals hit list, list axis or index I, because this is a DS list, not an array. I look forward to the day when GMRT is production worthy and we don't have to like worry about nonsense like this. But from here, if possible collision.ref.check object where did that come from? Return true. So the contents of our hit list here, this is not going to be a list of call objects the way that the infinities list is. This is actually going to be a DS list of obj collision proxy, because that's what actually participates in the collision checks in GameMaker world. And in order to actually get a reference to the call object which you can run the collision checks on, we are going to need to use the .ref there. So that's where that comes from. Anyway, if you do run into a precise collision check, we're going to return not true, not what I did right there. We're going to return possible collision.ref because we do want to return the collision object. If you don't run into any collisions in any stage of this operation, we are simply going to return undefined. And lastly, because this is a DS list, you do need to destroy those. We're going to need to DS list destroy the hit list at the bottom if you don't run into any collisions, and also if you return here at this point earlier in the code, DS list destroy like that. So because having to do this annoys me, this is not something you have to do, but something I often do is I will declare something like the hit list for a instance place list check as a static variable. And that way, this is only going to be created once, and then you don't have to worry about, like, making sure it's destroyed later, because you'll just recycle it the next time you call the function. You will, however, need to dslist clear that list, though. Otherwise, its contents will carry over from, like, in between runs of this method, and you don't want that, because then you'll just end up with, like, object references accumulating over time, and it'll produce the correct result if you do that, but it will slow down and it'll kind of defeat the purpose of this whole exercise. Alright, so that's add, remove, and check object. Check ray I'm just going to ignore, and I'm going to pretend it doesn't exist right now. Get objects in frustum. If I want the game to, like, function when I click the play button, I will need this to do something. Let me see. I'm just going to cheat for the moment, and I'm going to say everything equals an array, and then when we add an object to the collision world, array push onto the everything array, just the object. So we're just going to keep a list of everything in the game world like this. It is possible and also definitely ideal to do this correctly, but again, I might do that at the end of this video if it doesn't end up being like an hour long. Otherwise, I will possibly just leave that as an exercise to the reader. So when we do get objects in frustum, I will need to array copy. The destination is the output, destination index is 0. Source array is everything. Source index is 0. Length is going to be array length of everything. So we're not just going to return an array or anything like this, because this does need to work. This is a little bit complicated in the recursive structures, because you need to, like, build the list for each, like, recursive node in the tree, which makes it a little bit harder. Anyway, Now, before I run the game, I will need to go into the create event where this is all set up. Where is this? So this is where the collision world is like initialized. So we've got a couple different things to choose from: the quad tree, the octree, the spatial hash. I'm just gonna say var gm equals new call world game maker. That is going to be our like internal acceleration structure. And let me just comment all this out. I'll do side-by-sides of performance later on, but for now, collision world equals new call world, which is going to accept that GameMaker acceleration structure. Okay, I think that is everything that I need to do, at least to get the game working, like in a playable state. If I run this now, it's going to crash because something is not set before reading it. That makes it look a lot like I forgot to use a reference somewhere that I should have. What was that, line 92? That is, calling the displacement is, am I, oh, here. I need to return, not that. I need to return, the call object in the planes phase instead of just a true or false. I always forget, and not just when I'm doing these videos, but I always forget, like, when I'm, like, in my daily life that's how that works. Anyway, let's try that again. So the game starts. We've got our collision world. We have everything rendering because we're not doing any frustum calling checking. If I go and run into the side of these trees, we can see that I am doing collision checks against them. If I were to go and jump up over these trees, we can see that I'm doing collision checks against them on the correct vertical axis, and I can do things like jump over them, fall off of them. So this works. In general, if I wanted to visualize it, we could draw those collision shapes, and we could visualize the game world. So this works. At least for regular collision checking. We haven't done raycasts yet, and I definitely should do that. Let me see. Before I do that, let me go and make a commit. Implemented. We did not implement the rest of Call World GameMaker. We implemented most of the rest of Call World GameMaker. Okay, so let's do check ray now. So, in the same way that we have instance place list for checking collisions against, like, one object versus the rest of the world, we also have a couple of functions which look like collision line list. So this is going to give us a little bit of trouble because our rays in this 3D collision system are mathematical rays. They have an origin point and a direction, and they do extend in infinity in that direction. But GameMaker doesn't have any analogous collision line related functions to do raycast like that, at least not at the moment.
Hey.
Collision line list does take a 2D line with a defined start and an end point. So what I'm going to do instead is I'm going to kind of cheat, and instead of having a ray that actually goes off into infinity, I'm going to assume that in like your actual video game, you're not dealing with infinite rays that go off to infinity. And at some point in your game, you will, if you go far enough out from the world origin, you will come across a point where, like, there are no collision objects anymore. And I'm going to instead pretend that these rays are just very long line segments, and I'm going to pretend that they have a length of, like, 100,000 or something like that. And we'll just, we'll go from there. So, collision line list is going to take an x1, a y1, an x2, and a y2. And then we have the, obj call proxy, and we have precise, nah. These I'll use in precise collision checks anyway. Not me, no, we're just gonna set that to false, that doesn't matter. The list, hist list, hit list, we're going to need to create a hit list for this as well, and ordered is gonna be false. So let's go through this in order. So, I'm just gonna say, like, max distance equals 100,000. That might, on very small scales, cause, like, floating point inaccuracies, so you might want to make this a configurable option if you're like depending on the scale of your game world or something like that. I will want var x1 is going to be the ray.origin.x. Var y1 is going to be ray.origin.y. Those two are easy. If you remember how rays work in math class in school, you can probably figure out where we're going to go from here too. So x2, the other end is going to be x1 plus the max distance times ray dot direction dot x, and var y2 equals y1 plus the max distance times ray dot direction dot y. So we're going to extend this line out for some distance on along the vector of the ray on the xy plane. That's going to be our x1, x2, y1, y2. We also need the hit list. I'll do the static trick again. Static hit list equals ds list create. Ds list clear. To make sure that it's empty. I'm not going to be one of those people that says, like, you absolutely have to treat, like, your hit list like this when you're doing these kinds of collision checks, but I do like it because it allows me to be lazy and not worry about deleting them later, because only one will ever be created in the first place. Let's see, that's all the stuff we need to do ahead of time. Next, I'm going to say var n equals the number of collisions found in the collision line list function. As with the instance place list function, the generic shape collision functions will, they'll populate the list, and then they'll return the hit count. And then for var I equals 0, I is less than n, I plus plus. So the way that raycasts work, we will actually have to check every single object in this hit list, because raycasts, they do need to actually return the first object that you hit, like the nearest object that you hit, because like if you shoot a gun, it won't make sense if the bullet detects collision with like a wall that is on the other side of the building. That's just silly. So we're gonna have to say we're gonna iterate over the entire list, and if we can say, what did I call it earlier? Potential collision, possible collision. Possible collision is gonna equal the hit list access or index I. If possible, copy and paste was invented for a reason. If possible collision dot ref dot check ray, and the check ray method on an individual object is also going to take the ray, the hit info, and the group. So if this returns true, we're not going to return true because again we do need to check all of them. I'm going to say var result equals false. If you do find a collision, result equals true. The hit info is updated automatically when you call the check ray method, and it'll update it with like the nearest result found and whatnot. And when we're done, return result. And that should be our raycast. I don't think there's anything else. There is a bit of a special case. So if x1, y1, x2, y2 happen to be the same coordinate, like if you're like doing a raycast exactly pointing into the xy plane, you might want to handle that specially with the collision point list function instead. I don't know off the top of my head if collision line list will behave correctly with a line with a like length of 0. I actually don't think it will. But first, let me go and run the game. And what was it? T to throw a ball. So if I do that, that's going to do the raycast. It's going to bounce off of the shapes, and it's going to reflect off the yeah, this one in the middle doesn't actually exist. I don't actually know why that's there. I don't remember why I put it there. But we can see now when we follow the ball, when it does its little raycast, it's going to produce the correct result. All right. So to handle the special case, we can say something like if x1 equals x2 and y1 equals y2, then where? I think I hit page down instead of the down arrow key or something like that. Then instead of, so if this is the same point, we can do collision point list instead. And we can just basically update the argument list. So we've got the object precise as false, not me as false, the hit list, and ordered as false. Feather will yell at you about declaring variables like this, so if you want to keep Feather happy. And for the record, it's right. but it just happens to be something that you can generally get away with in GameMaker without consequence. Define the like the variable n outside there. Make sure it's initialized in the correct scope. Anyway, I don't really have a way to test that without like hard coding the vector that you throw the ball on, because like I can't like with like a third person camera just like perfectly line up a shot on the XY plane, but that might be something to consider. I think I'm gonna go and do a do another commit here. All right. So, is it time to talk about performance? I think it's time to talk about performance, which I assume is what you're here for if you clicked on this video. So, I am going to uncomment all this, and we can flip back and forth between... I'm going to look at the quad tree, the octree, tree, and the GameMaker collision world. Let's see. Where am I defining these collision world types? There we go. So, I'm just going to give the debug overlay a way of actually accessing this when you click on the dropdown. Where is the dropdown created? I think that's down at the bottom here. Here we go. Like that. So now if I run the game, and if I were to go and look at the performance readout, so this is going to be a little graph of how this is going to perform. Look in particular at the red. So the red is going to be basically the step event when we do our collision checks. Let's see. If I go and... Can I increase the number of things in the world to make it a little more dramatic? There we go. All right, so that took a... that hitched a little bit when we set that up. But we can see that the red line over here is oscillating between maybe, I don't know, 3 milliseconds and 7 milliseconds. It looks like it's stabilizing around maybe 6 in most cases. It's spiking a little bit, probably if like the Windows operating system interrupts the game thread in the background to run some background process, causes a spike. But we'll call it for about 5 to 6 milliseconds in general doing that. That's the octree. Tree. If I look at the quad tree, it's going to take a couple of seconds to rebuild. And looks like it's about the same in this case. This collision world is fairly flat, so I think most of the collision objects, or if not all the collision objects, are going to be roughly on the same plane anyway, so there's not going to be a huge difference between a quad tree and an octree. Tree. If I go and switch over to Call World GameMaker, so there is a small hitch when we went and created our like all of our collision proxies, but you'll notice that the red line now, as I run around in this collision world, is tiny. It's probably not much more than 100 or 200 microseconds, so 1 or 2/10 of a millisecond, and it still does all the things that all the collision related things that we were able to do before. We can run around between the trees, we can jump on the trees, we can fall off the trees. If we had other collision shapes, we would still be able to engage with them. But because GameMaker's 2D collision system is just that fast, we can actually save... And it almost doesn't even make sense to produce a number in terms of like how much faster this is than what we were doing before, because it depends on like how much stuff is in our world. But we can save a substantial amount of time doing our collision checks in our broad phase by using GameMaker's 2D collision system for this. So a few final notes on this before I put it down. There's a couple of ways that you can break this system that some of you might have noticed already. The most obvious one is like making sure that the GameMaker instances are deleted when you're not using them anymore. It's possible to delete the entire collision world and all of the collision shapes and everything else that comes along with it by like dereferencing it and letting it get consumed by the garbage collector, but without also manually deleting the GameMaker instances that go with them. In my quote-unquote official version of this that I've published on my itch page, and that you can see on the main branch of this project in the GitHub repository, I have written a little weak ref tracker that will keep track of the structs that the collision proxies are bound to, and it will just destroy the collision proxies if the weak ref dies. I'm not going to go into that here because this video is already 40 minutes long, and that's enough for me. There's a couple of other shortcomings. If you are one of the people who like to do the instance deactivate all trick for like pausing and stuff, that will also deactivate the collision proxies. I don't know how likely you are to need to be able to do collision checks during a pause screen, but be aware of that. I don't like the instance deactivate all trick for reasons including but not limited to this. Additionally, if you use the quadri-octree spatial hash structures for accelerating 3D collisions, then you can actually have multiple collision worlds active at the same time and they won't interfere with each other because objects will only exist in one or the other. But if you use this collision proxy system, then if you try to have multiple collision worlds existing side by side for whatever reason, you will run into problems and objects in one world will still collide with objects in the other. Lastly, and I haven't benchmarked this thoroughly, but I'd be curious if anybody else does, but because the GameMaker 2D collision system does operate on the XY plane, I suspect that it will perform better and it will eliminate the most results quickly if your gameplay takes place using the XY plane as the horizontal plane and the Z axis as the vertical axis. And you can just imagine, like, if you view your world from a top-down or a side-on view, just like the instance place list function will detect fewer hits on average if the XY plane is the horizontal plane and the Z axis is the vertical axis than it would if you flip that around. But I think that's all for this. I think I can finally put this 3D collision system to bed. If you want to see the code for this, look for the GitHub repository in the description of the video. Like I said earlier, there are also like official releases of this code on my itch page and in the GitHub releases tab that have slightly more robust solutions to some of the problems I've described here. I like to post videos about all kinds of weird stuff you can do in GameMaker, so if you're interested in any of this, feel free to subscribe. Sorry that there haven't been as many of those recently. There have been computer problems that I have to deal with fixing, and that has gotten in the way of making videos. I have a Patreon, so if you wanted to contribute to the channel, links to that can be found in all the usual places, and if you felt like pledging, I definitely would appreciate it. You should all go check out Wizard X and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. It has a demo, you can play it, go wishlist it, do all those things. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, Zach Robinson, Squarecrow, Spide Games, Pixelated Pope, Paradox, Nykotic, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, Brenton, Bokeh Dev, and Argo the Knot for supporting these videos. If you want to join the ranks of these very cool people, head on down to the Patreon page in the video description to join the fun.